Dilip, what's next?
Yeah, I think the sessions are very exciting, and we are sort of deep diving into a lot of aspects. Our next speaker for today will be Jake Hattis, who is the CIO from LongView. He's also going to talk to us something around graph in some way.
Oh, nice.
He's going to talk to us about how to use Gremlin API and Apache Airflow to facilitate complex system integrations.
Wow.
So,
Yeah, I feel like
Jake, over to you.
we're a bit Gene did a little bit of work for us in showing us what the eventual application of graph can do for us, especially with financial institutions and fraud. What
Yeah.
I'm going to be talking about is how you can actually, you asked that question just now, how you get that data into the graph in the first place. And so my session here will be talking about sort of our journey and how we went through, and then I'll sort of share with you how you can not only model your data for graph, but then also implement that with continuous delivery. We've done that through a number of different systems, including Apache Airflow. But I'll go in a little bit more detail around what sort of graph is, what Gremlin is, which is the language. So a little bit in the last session, the language to traverse a graph or to speak to a graph. We'll go all into it. But a little bit about myself, just as you spoke. My name is Jake Hattis. I'm the CIO of LongView. And a little bit of plug about LongView. LongView is a property service firm based out of Melbourne. We're here down in Australia, if anyone is listening from the Southern Hemisphere. We're a little bit of a different company in the sense, if you work in property down in Australia or you've heard of it, it's often very operational based. The data and analytics is often separate. It's by different providers, different companies, and what makes us a little bit different is that we try to combine those two. We have field expertise, and we need analytics, and that requires a little bit of a different approach in terms of technology. And about a year and a half ago, we realized that across our business, we had 7 or 8 different business units, all using their own individual work management systems. And one of the business units would enter data that would be applicable to one of the business units over here. And so we needed to get data from there over to there, but we didn't necessarily want the business unit A over here to have to use the system for business unit, the business unit over here. And so we needed to implement an integration layer, and a kind of database layer that sits across our ecosystem, across the different work management systems, and connect them. And so when we started to look into that and what the possibilities are, we came upon Graph and Cosmos DB, and we ended up using and building our database layer using the Gremlin API in Cosmos DB. And so I want to share with you sort of why we did that, how that came to be, and how you might potentially be able to do that yourself in your business. Because as you'll see, and as we go along, Graph and Gremlin allows you to essentially scale complexity. And you'll notice if you have any number of different systems in your business, it becomes very, very complex very, very quickly. So just a little bit of agenda of what we'll be going through. First bit will be just around sort of modeling your business data using Graph. Talk about what is Graph, what is Gremlin. We'll talk about and then so how you can use a structure to then model that data in a graph structure. And then we'll talk about the actual infrastructure behind it and how you can get the data from any of your work management systems or any systems that you use into the graph continuously. So we'll talk about the systems involved there, the architecture, and sort of what is happening from a continuous development perspective using the architecture that we've worked on. And not to say that that's the end all be all, it's just some of the insights that we've gleaned as we've worked on them ourselves. So let's kind of talk about, graph and modeling. And the first thing is, for those of you who don't know what graph is, it's a database. And I like to think of it as really firmly perfect meshing of a NoSQL database and an SQL database. The benefits of an SQL database is that you have that relational tabular data. It allows you to sort of connect various different tables and various different items all together, and you're able to sort of connect all of those into various views and access that. But it's not very flexible, right? Not like SQL, NoSQL, which gives you that sort of JSON document structure that allows you to change structure and schema depending on the document itself. But the problem with NoSQL is that you don't necessarily have that relational aspect, that relationship. And so what Graph does is it takes that flexibility of the SQL, of the NoSQL document, but then gives it a relationship. And so if we look at this sort of structure here, in Graph, they're defined as sort of nodes and relationships. And you sort of saw that in the last session where we see sort of IP addresses, we have houses, those are different nodes and they're connected by a relationship, right? But that sort of defines the graph structure, and at its base, you sort of build from that sort of simple idea. And Gremlin, which is just one of the various languages and APIs that are available in Cosmos DB for you to interact with. I think Cassandra is another one that you can use, but Gremlin is just the language that we use to traverse the graph. And when we say traverse, it truly is traverse because you are hopping from one node to the next. And you'll see as I have a few examples here that show you sort of how Gremlin interacts or sort of how to think about the graph and how you write those queries to interact with it. To do that, I've sort of given you a bit of a model. And at the top of here, you can sort of see what it looks like in the graph, right? So we have nodes. We have 3 nodes here that are all sort of the same label or collection. They're all people, all with different names. So they're individual items. We have Frank, we have Jake, and we have Bruce. And then we have the relationships between them. But one thing that you'll notice is that there's a directionality to the relationship. So one node needs to be connected to another, but there needs to be some kind of indication of a direction between sort of where we're going there. If you think of a tree, it has to branch out from somewhere. And the same is true in terms of a graph. And that's why you see when you look at the various sort of models out there, graph looks like this huge web. It's beautiful. But that is what lies in its power, because you can traverse it and you can aggregate the various relationships that are coming out of it that you're creating inadvertently or consciously or unconsciously. So when we think about Gremlin and how that works, it all sort of stems from that idea of directionality between the different nodes. So if we look at this query here, we are essentially asking the question, who are Frank's friends, right? And so we have Frank and we have Jake and Bruce. We're hoping to figure out who Jake and Bruce are. How does that represent itself in Gremlin? Well, every Gremlin query starts with a g.v, and if you were to just plug in g.v into your terminal, you return every node in the entire graph. So if you have 100 million nodes in there, all of them would come back. So we can now sort of, this next section here, which is just to filter it and center ourselves on the point in the graph that we want to start with. And then we're going to move out from there. And that's sort of what literally the keywords are out and in, right? So in this query, we're centering ourselves on Frank, and we're asking who is friends with Frank with a direction out. So it's this relationship between Jake and Bruce. When we run that into our terminal, we're going to get a list of nodes or objects that correspond to that relationship from the corresponding node. And so that's a little bit of Gremlin. What I wanted to sort of show you is and especially in our business, because we were connecting various different business units in the work management systems, we needed to bring them together in a way and build out the relationships between the existing systems. And so data that was coming from one system and we needed to define the context of that data in terms of the other systems. And so what I've tried to do here is I've modeled it out what you would see using SQL. So we have two different systems here. We have a work management system that manages, because we're in property, we do inspections, we manage applications and tenancies corresponding to properties. But in our ecosystem, we have a system that manages the inspections and applications, and then a separate system that manages the ongoing tenancies in the properties that we manage. And then, of course, so I delineated between those two systems between the colors. Of course, contacts are going to be coming from both. So, when we're pulling data out of one system, it could be via API or another database, backend access. We're pulling that out, and we have applications inspections. We have contacts from one system. We have contacts, tenants, and properties in the other, and they're all many-to-many relationships. So in SQL, how we would represent that is we'd have our sort of core tables corresponding to the sort of key entities, and then we would connect them using these joining tables. If we were going to look at that as it represents in graph, it becomes drastically simpler, because we don't have to worry about extra sets of tables to join the various tables together, because it's inherent in the relationship. And that's another sort of core aspect of graph, is that it is on a one-to-one basis. So, a record, if you think in terms of SQL, if you were to connect one record to another record, you could do that, and it would represent itself in the graph. And so, for us, we can remove these joining tables and represent them through relationships. Let me pose a question. According to this sort of structure, right? When did the current tenants of a property, say Prop 1, with an ID of Prop 1, when did they inspect the property? Usually what we see in terms of property is someone inspects the property, they apply for the property, and then they become a tenant, and once they're accepted. So, if there was a business question of, when did this tenant, the current tenant, inspect the property, how would we necessarily pull that out of the database? If we had structured that integration, that database layer, using SQL, we would need to write this really nasty long query, lots of subqueries, joining tables, just to pull out a single piece of data. If we look at that corresponding query from Gremlin using graph, it suddenly becomes just a single sentence. And you can kind of see what we mean in terms of traversing the graph, because it reads like a sentence, right? So, we're centering ourselves on Prop 1. That's the node that we're starting with. We want the tenants that are renting the property currently. We want them going to move to the contacts that are renting, that are tenants that are renting the property. We're going to go from that contact node out that are connected to inspections. They attended an inspection, and that inspection was for this property 1. And then we can just pull out the values, the date. So it becomes very simple to manage those complex relationships using graph. And I often like to talk about it, but when we started modeling out the data in our business for across, I think it was 2 systems in particular, just the beginning sort of cornerstones of these systems, and I just found myself, I had 15, 20 different tables that I was working with. I wasn't sure how I was going to be connecting, contacts over here to contacts over there, and what if that inspection connected to this application? How would all of that work, and how would I maintain that? Because that's highly complex, and that's just 2, and we have another 5 that we need to build in there. And my chief data scientist, reached out and was like, "Oh, have you ever heard of graph?" And I think it was within 2 or 3 weeks I was able to essentially simplify that entire process, the entire complexity, into a working model, and it was the right call. We were able to essentially map out data and relationships between that data effectively in a scalable manner across the entire business. And so, when we're talking about how to model your data, because it does take a little bit of a different frame of mind to when you're sort of looking at that data that you need to connect. I always find it to be helpful to sort of look at the structure in terms of a table, And sort of if we're sort of reading this, we have only 3 columns. We have the node, we have the relationship, and then we have the node. If you think about it that way, I always found it very helpful because you start with the entity itself, and then you can expand on what those relationships are to other nodes. It could be the same node, right? But it all starts with just identifying what it is are those, those tables, what are those entities that you need to label and collect, and that will scale, or you need to identify as a group. So, in this example, which we're just continuing on from before, we only have a few nodes. We have contacts, inspections, applications, tenants, property, pretty easy. And then you build out those relationships, or you start to flesh those out, or what possible relationships could there possibly be there. So, and this is just a very simplified version of this, but you can see where you can continue to expand it out. So a contact, here we have a contact that attended an inspection, and that relationship is key. But a contact could be, say, a brother of another contact. A contact could be an aunt. It could be a referrer for another contact. You can just start to see where this simple table becomes very complex and very long, because there are so many different relationships that you can define. But once you have an idea of not only what those relationships are and the directionality, so if we're reading sort of left from right, we know that we're defining a relationship from a contact to an inspection. And so if we were going to look at that and think of that in terms of Gremlin, we would think, a contact out, attended in, and we would receive an inspection, because we've predefined that relationship and the directionality there, left to right. We can then expand, because we have our relationships. You can kind of see here in this map here, we've taken the relationships from before and we've just mapped them. But for each of those nodes, each of those sort of labels that we have, there are properties or there are pieces of data that we can use to fill out that information. And so, and that is accessible to us when we're looking to expand in that kind of those queries and different pieces of analytics or pieces of information that we need to pull when accessing different pieces of information. And so, for an application, we might have the date submitted, the application status, any comments that we have, for a property, you have your address fields, your status, your latitudes, your longitudes. You can start to fill that. And if I haven't sort of scared you already with how much data you can, pack into this simple structure, the relationships themselves can have properties as well. So, we could have a date field for this registered for relationship. So we know it might be inherent inside the inspection, so we may not need it. But you can start to see where you have relationships in the node, you have properties in the nodes, and then your properties in the relationships. And so it becomes a very meaningful way to represent reality that you previously couldn't do without bringing in and having to manage that scaled complexity. So now that you have that sort of, that model, you've modeled it out, you need a way to actually implement it. And you need a way not only to, maybe you've established a graph, but you need to get that data out of the systems. You need it to go into the graph, and you need to keep it updated, and you need it to be robust and available, and you need it to be independent. And so what does that necessarily look like? What is that architecture? In our experience, we used we found the best system that worked for us was a system called Apache Airflow. And if you don't know what Apache Airflow is, it's an open source data orchestration tool. You install it on a server. We have ours on an Azure VM. And essentially what it does for you is it consolidates your pieces of data orchestration or your data processing to what they call DAGs. And the DAG is very specific. If to simplify it just greatly, if you have system A and you have system B, and you need to get data out of system A, and you need to do some stuff to it and push it into system B. All that stuff that happens in the middle is a DAG, a DAG. And so in Apache, in Airflow, what you can do is you can define specific DAGs, and within a DAG, you have tasks. So a great example of this is, we are, at least at LongView, we've defined some standard tasks that we have for each DAG. We have a pull, we have a process, and we have a push, and you can expand from there. There may be some DAGs where we have multiple pushes because maybe that DAG needs to push into multiple data sources. Maybe it's going into the graph, maybe it's also going into an OLTP database, or maybe it's going into an blob storage for backup. You can define all of that through Airflow. It handles all of the, it handles the logging for you, it structures it for you, it executes it on a trigger. Airflow is a really amazing way for you to expand that, that especially as you grow larger and as you need more complex data orchestration tasks, it's a way for you to manage that in a scalable manner, in a more robust and available manner as well. So we used we implemented Apache Airflow, and of course we use GitHub for our sort of our versioning and our code development, and then we used the Azure Container Registry to then deliver the actual code that's being conducted inside of Airflow. So inside of Airflow, when we're talking about DAGs, you have a number of different options for you when you're executing sort of this data processing. You can operate sort of within Airflow itself and use some of the native APIs. You will have the option to use a Docker container and containerize that solution, and then use the entry. The DAG essentially uses the entry point of that Docker image to then execute the code. And so we've chosen to use that because we can deploy the latest solutions, the latest DAG, and the latest container or code that needs to be executed in a continuous development through an architecture that looks like this. So let me walk you through sort of what that looks like. So we have we have our Airflow server. We have a container registry which holds all of our Docker images that we use to deploy to that we use to run our DAGs. And then we have two specific repositories in GitHub. We have one that is the actual DAG itself. So within that repository, there is the code that runs the DAG. There's also the Docker file. That is synced as a submodule to this, the company-wide DAGs repository that holds all of the DAGs that the company is executing and running at the same time. We've initialized that as a remote repository on the DAGs folder in Airflow. And we then use the container registries to push our latest image. So what that means is when we're developing, we can commit a change or an update to the DAG file, whatever it is, whatever that data processing file that we need to do. We commit it to GitHub. That updates the repository in GitHub. We then use a GitHub action to connect via SSH to the Airflow server to update the local repository of the Airflow DAGs repo, which then updates its submodule. So that change that comes through, that we just pushed through, is then immediately available on the Airflow server. So we don't have to worry about a CP or any sort of file transfers to get that in there and active. It's ready to go almost the moment that we commit it. And then we have a separate file that we use to then deploy our Docker image, the latest build of that Docker image to the container registry. So what that looks like when a DAG executes is in a DAG you sort of schedule what that is to execute and when it's supposed to run. When it does that, it pulls the latest image from the container registry. and executes the DAG, but that the DAGs that are defined are from our company-wide Airflow repository. And so in a single, we can very easily and agilely update a DAG or data processing, and we can deploy it, and we don't necessarily have to worry about it being present in the right places, or that the DAG that's running on Airflow is using the latest image in Docker. It's all seamless, and so we can focus more as a team on the data itself and how it's being processed in the code, and making sure that it's bug free and able to actually run. And so when you sort of combine all of this together, we can essentially update we have DAGs that we have 20, 30 different DAGs that are running at the same time, all pushing data from our various systems into our graph that we can then use to either facilitate data from one end of the business to the other, or we can do analytics on the relationships that are being generated from the data that we pull. Or in other cases, we've actually built integrations between ourselves and other companies using our graph database for people to access it. It has truly sort of revolutionized the way that we have integrated data, and thought about how the relationships between the different elements of our data itself. So that's everything that I have on my plate. Thank you for listening to us, and I'll be in the chat if you have any questions.
Thank you.
Hey, yeah, Jake, I think this was a good 101 on graph and how to approach data modeling for graph databases. So I had a couple of questions on this Apache Airflow, right? So
Yep.
how different is this when compared to a ETL tool? Because you're talking about DAG and you're talking about pushing the data to multiple destination systems.
Yep.
How different is it from ETL, and can you configure something which is specific to every destination, like send some level of data to system A and don't send something to system B? Can we do all those things in
Absolutely, and yeah. So Airflow, I think, is just another ETL tool. There are so many out there, but it's
Okay.
just another one. The reason we really liked it and we engaged with it is that it did give us that amount of control. If we needed to push, if we did need to push one form of data A into system A and another form into system B, we have that potential. We actually were just writing a DAG the other day where we were taking a dump of a Parquet file, pushing it into blob storage, taking that same data, manipulating it, and then pushing it into an OLTP SQL database. So it's all it gives you that control, which is exactly what you want, because that data needs to be in the right format to go where it needs to go, right?
Sure. And this consolidation of multiple business teams that you were talking about, right, for which you implemented the project. So was the destination database, in this case, Cosmos DB and Gremlin, which was later used for further analysis and deep diving into the data in some way, or this was just one of the databases which was a destination in this case?
No, so we built a comprehensive database layer in Cosmos DB with the Gremlin API, and that had all of the data that across our business within that graph. Okay. It isn't completely done yet. It still continues to grow, but we have found that in addition to that graph, we use it to then influence other databases that we're continuing to build OLTP or OLAP solutions.
Makes sense. No, I think this was a really good lesson for somebody like me who is not like deep diving into graph right now, but I was able to correlate a lot of aspects of how to visualize things, and it was it was good. Thanks a lot. Aria,
Yeah,
any
thank you.
thoughts on this?
Yeah, I thought it was really cool because I really know about like we're using Airflow most times and moving the data. Most times I've noticed like a lot of systems like copy the data over the raw data and then try to read that back so you can do some of the cleaning instead of doing it on fly in case the dog breaks. So yeah, I think with this session and the previous ones, having this whole intro to graph and everything, I think was really cool. So I'm like, okay, yeah, it's nice. Thanks a lot, Jake.
Thank you for having us.
Awesome.